So this is one where we talked about transformation, but we also talked about needing the equations to discern the transformation. So we have a positive and a negative linear function. F of x is the negative function. We can see that f of x is, the y-intercept is 1, and it is going up 2 over to the left 1. So it is negative 2x plus 1. And then g of x has a y-intercept of negative 3, and it's going up 2 to the right. No, that's just kidding. Up 6. Is that what we said? Yep, up 6 to the right 1. Okay, and then minus 3. So we needed to find out, like, what is the difference between these? And we said that in order to get from this x value to this x value, you'd have to multiply by a negative 3. And then to get from this y value to this y value, you have to multiply by a negative 3. So therefore, to get to g of x, k equals negative 3 times f of x. I don't think I explained that very well. I was having a terrible foggy brain with this one that day. But if you can see, like, what is the relationship between f of x to g of x? It's negative 3. So that's what goes in for k in this equation here. All right, moving along. This was our fun, and I use that word very loosely. So we have Matt and Phil making cookies, and we know that Phil makes 25% more cookies than Matt. So therefore, we're using Matt as our standard. Phil makes Matt's cookies plus 0.25 more of Matt's cookies. So you combine these together to make Phil. So therefore, Phil is 1.25 Matt plus Matt made some cookies. So Phil and Matt make cookies. And they only sold 80% of them. Okay, so we have to multiply this times 0.8 or 8D, if that helps you to understand that, you know, you had 20% left over, so you're selling 80%, and then you're multiplying that amount that you sold times 25 cents a piece. So you can set this all equal to T or whatever letter makes you feel better for the total money earned. Now this was part A. Enter your equation and your explanation in the space provided. Then they're going to set this equal to $72. So we're going to have this 0.25 times 0.80 times 2.25. I just combined like terms. And that's going to equal $72. So therefore, you need to do some math here to figure out the amount of cookies. Okay, because time is of the essence in these recordings. So basically, when you multiply 2.25 times 0.8 times 0.25, you're going to get 0.45 m equals 72 divided by 0.45. And you're going to find out that Matt himself made 160 cookies. Therefore, you stick that back in to find out how many, multiply that times 1.25. And you find that Phil made 200. So I've adjusted this. So now next year, they may sell the cookies for 50 cents a piece. So change your 25 cents to 50 cents. They will only sell, they predict that they will only sell 70% because of the price increase. But will it help that they've increased the price? Well, probably. And this time around, we don't need to write the algebraic expression of 2.25m because we know that they've made 160 plus 200 cookies last year. And then we're going to find out with these numbers how much will they now make. So if you put or you go ahead and multiply all this, you're going to have 360 cookies times 70 cents times, 70% times 50 cents. And you're going to come out with $126. So that's significantly more. Even though they sell less, they make more money, obviously, than they did last year. It's a little over $50 increase. Okay, question 15. So this is more along the lines of statistics. So you have all these different statements, and you have to figure out which ones are true. So they polled a total of 200 boys and girls. 80 of them were girls. So if you take 80 and divide by 200, you will find that equals 40%. So this was true. How about that 70% of the participants preferred A? Well, if we travel down here, here's A, and we know that 70 participants preferred A, and that's 70 out of 200. Therefore, that actually is 35 out of 100, and so that's only 35%. So this is not a true statement. How about 20 of the 120 of the boys preferred D? So here's D, and this is 20 out of 120 boys. So that is true. And then 10 of the 35 of the participants who preferred B were girls. So here's B, and there's 10 out of the 35 total were girls. That is also true. Okay, and then the last one says the proportion of boys who preferred C is equal to the proportion of girls who preferred C. The proportion of boys was 30 out of 120 boys that preferred C, whereas the proportion of girls was 30 girls out of 80 total girls that preferred C. So they are not equal.